Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're diving deep into the world of profiling and monitoring tools. We're currently in our JVM Experts season, exploring the chapter on performance tuning. Joining me as always is our JVM guru, Victor. Victor, are you ready to unravel the mysteries of JVM profiling?
Absolutely, Sheila. I'm excited to share insights about these powerful tools that can help developers optimize their Java applications.
Before we jump in, let's start with a quiz question for our listeners. Here's a tricky one. True or false? Using profiling tools always slows down your application significantly in production. Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It touches on a common concern many developers have when considering whether to use profiling tools. I'm sure our listeners will have some interesting thoughts on this.
Now, Victor, let's start with the basics. What exactly is profiling in the context of JVM applications?
Great question, Sheila. Profiling is like giving your Java application a comprehensive health checkup. It's the process of gathering detailed information about the behavior and performance of your program as it runs. This can include data on CPU usage, memory allocation, thread activity, and more.
That's a helpful analogy, Victor. So, if profiling is like a health checkup, what are the different types of checkups, or rather profiling, that we can perform?
There are three main types of profiling: CPU profiling, memory profiling, and thread profiling. CPU profiling helps identify which methods or code blocks are consuming the most processor time. Memory profiling tracks object creation, garbage collection, and helps detect memory leaks. Thread profiling analyzes thread behavior, helping to identify deadlocks or concurrency issues.
That's fascinating. Can you give us an example of how each type of profiling might be useful in a real-world scenario?
Certainly. Let's say you have a web application that's running slowly. CPU profiling might reveal that a particular database query is taking too long to execute. Memory profiling could show that your application is creating too many temporary objects, leading to frequent garbage collection pauses. And thread profiling might uncover a deadlock situation where two threads are waiting for each other, causing the application to hang.
Those examples really bring it to life, Victor. Now, I've heard of tools like JConsole and VisualVM. Are these profiling tools, and how do they compare to other options?
Yes, JConsole and VisualVM are indeed profiling tools, and they're both included with the JDK, which stands for Java Development Kit. This makes them great starting points. JConsole is simpler and focuses on monitoring, while VisualVM offers more advanced profiling features. However, there are also commercial tools like JProfiler and YourKit that provide even more sophisticated analysis capabilities and user-friendly interfaces.
Interesting. So, if I'm a developer looking to start profiling my application, how should I choose between these tools?
It really depends on your needs and budget. If you're just getting started, VisualVM is a great free option that offers a good balance of features. For more complex applications, or if you need advanced features like remote profiling or custom plugin support, you might want to consider a commercial tool like JProfiler or YourKit. It's also worth noting that many teams use a combination of tools for different scenarios.
That makes sense. Now, once we've chosen a tool and gathered all this profiling data, how do we actually interpret it to improve our application's performance?
Great question, Sheila. Interpreting profiling data is both an art and a science. Generally, you're looking for hotspots, areas of your code that consume disproportionate resources. In CPU profiles, look for methods that take up a large percentage of time. In memory profiles, watch for objects with unexpectedly high allocation rates or large retained sizes. For thread profiles, look for long-running or blocked threads.
That sounds complex. Are there any common pitfalls developers should be aware of when interpreting profiling data?
Absolutely. One common mistake is focusing too much on micro-optimizations that don't significantly impact overall performance. Another is misinterpreting sampling-based profiling data as exact measurements. It's also crucial to profile with realistic data and workloads. Profiling results from a development environment might not reflect real-world usage patterns.
Those are great points, Victor. Now, here's something I've been wondering about. Does the act of profiling itself affect the performance of the application being profiled?
That's an excellent question, Sheila, and it touches on a key consideration in profiling. Yes, profiling does introduce some overhead, which can affect the application's performance. The extent of this impact varies depending on the profiling method and tool used. Sampling-based profilers generally have less overhead than instrumenting profilers. However, modern profiling tools have made significant strides in minimizing this impact.
Interesting. So, how can developers balance the need for detailed profiling information with minimizing the impact on their application?
It's all about being strategic. For development and testing environments, you can use more intensive profiling to get detailed data. In production, you might use lighter-weight monitoring tools or sampling profilers with very low overhead. Some advanced tools even allow you to dynamically adjust the profiling level based on certain triggers or conditions.
That's really helpful, Victor. As we wrap up, could you share some best practices for using profiling tools effectively?
Certainly. First, always profile with a specific goal in mind. Don't just collect data for the sake of it. Second, establish performance baselines so you can measure improvements. Third, profile in different environments, development, staging, production, to get a comprehensive picture. Finally, make profiling a regular part of your development cycle, not just something you do when problems arise.
Those are great tips, Victor. Now let's return to our quiz question. True or false? Using profiling tools always slows down your application significantly in production. Victor, would you like to reveal the answer?
The answer is false. While profiling does introduce some overhead, modern tools and techniques allow for low-impact profiling, especially in production environments. With careful tool selection and configuration, you can gather valuable performance data without significantly affecting your application's speed.
Thank you, Victor. To summarize today's episode, we've learned that profiling is a powerful technique for understanding and optimizing JVM applications. We covered different types of profiling, CPU, memory, and thread, and discussed various tools like JConsole, VisualVM, JProfiler, and YourKit. We also talked about interpreting profiling data, common pitfalls to avoid, and best practices for effective profiling.
That's a great summary, Sheila. I hope our listeners found it informative and are inspired to start profiling their own applications.
Absolutely. In our next episode, we'll be exploring common performance pitfalls in JVM applications and how to avoid them. Until then, keep optimizing those JVMs. And don't forget to subscribe to JVM Internals Crashcasts and leave us a rating if you enjoyed this episode. Your feedback helps us improve and reach more Java enthusiasts. See you next time.